Hello, I am Professor Maria Luisa Bringas from the Joint China-Cuba Lab for Neurotechnology at the USTC and collaborator researcher at the Cuban Center for Neuroscience. In this lecture, following on the explanation of terms done by Pedro, I will explain 4 main examples of how to use QEEG in clinical settings. I don't have any disclosures to declare, and we want to start mentioning that in the 1990s, our group has been applying quantitative EEG to study brain dysfunction using variable resolution electrical tomography, VARETA, as explained by Pedro. In the slide, you can see some of the papers we have published on the topic. We shall concentrate on 4 types of clinical hypotheses that our group has dealt with. First, can we detect brain impairment in presymptomatic patients with Alzheimer's mutation? Second, what is the long-term impact of early malnutrition on the brain and cognition? Third, are detectable differences in the brain electrical activity COVID pandemic patient with negative or positive PCR? And 4, what is the efficacy of the novel neuroprotective compound in Parkinson's disease? Okay, can we detect brain impairment in presymptomatic patients with Alzheimer's mutation? The quantitative EEG has been employed for early detection of Alzheimer's in studies in collaboration between Cuba and Professor Lovera in Colombia. In the top left, you can see a map of the country in which the collaboration started near 3 decades ago. Lovera identified in 5 family an autosomal dominant mutation, presenil1 E280A. This mutation has a 100% penetrance with subjects at age 40 exhibited Alzheimer's dementia. In the top middle, you can see the one family tree with affected people shaded in black. In the right, you can see a very old version of the Medicine 128, a device produced in Cuba since the 70s, which was transported to Colombia. The experimental design was to select 3 groups: the mutation with mild symptoms, people with mutation, no symptoms, and the people without mutation, of course, no symptoms. The top left graph shows the average EEG spectrum for each of the 3 groups for the frontal and temporal electrodes. The Alzheimer's group showed a highest increase of power in theta and decrease of alpha, with the non-carriers having a normal pattern. On the left bottom, you see the voxel-wise ANOVA for the VARETA image. Notice the clear increase in theta for the Alzheimer's group. This is an early molecular image with the quantitative EEG. On the right is a histogram of the area under the ROC of the discriminant analysis to distinguish the patient from the mutation from the control group. On the top scalp, on the bottom, VARETA. Notice the improvement performance with source analysis. Using the harmonized norms described by Pedro, we obtain even better discrimination between groups, as can be seen by comparing the left and right ROC. A box plot of the classification using the classical QEEG on the left and harmonized QEEG on the right shows that the discrimination between groups is much clearer with harmonized QEEG. The second question is, what is the long-term impact of early malnutrition on the brain and cognition? The Barbados Nutrition Study showed the long-term impact of malnutrition on cognition using the resting state EEG. The data set comes from a longitudinal study started in 1967 to 2018, directed by Janina Galler. The subjects suffer protein energy malnutrition in the first year of life. And the EEG was recorded in 1978 when the subjects were 5 to 11 years old, and in 2018, 40 years after. We developed a pipeline for the EEG analysis of the long-term effect of early insult in the brain. And this is from the Jorge Bosch paper in Neuroimage. A linear mixed effect analysis showed the EEG frequency to the left and location at the right that changed during the period of 45 years. On the left is the analysis set up to test the classification accuracy of harmonized QEEG descriptors. The large set is the totality of the multinational harmonized QEEG data set. We use Cuba, similar to Barbados, in ethnic and cultural background to eliminate the QEEG batch effects. We then use the Cuba batch corrected harmonized norms to discriminate between children that had malnutrition during the first year of life from healthy controls. Note that the EEG was recorded at school age. On the right are the ROC of the discrimination for classical QEEG and different variants of harmonized QEEG. While all QEEG methods are quite good, however, the batch-corrected harmonized QEEG gives the best results with much increased performance. Additionally, the QEEG demonstrates the mediating effect of the brain on the long-term effect of child malnutrition and middle-age cognition. Another question: are there detectable differences in the brain electrical activity COVID pandemic patients with negative or positive PCR? Cuba carried out a longitudinal study of people who were hospitalized due to possible COVID infection. These later were classified as having COVID, PCR positive or not, PCR negative. EEG and other tests were carried out 1 month after discharge from the hospital. In both PCR positive and negative participants of the study, alterations were found in the EEG spectrum, which were also reflected at the source level. In a similar design to the malnutrition example, we use a harmonized QEEG descriptors to discriminate between PCR positive, PCR negative, and subsample of the Cuban healthy controls. COVID-B in green, used in the multinational norms. As can be seen on the right, the controls are very different from the hospitalized participants. Deviation from the norm increases as one goes from controls to PCR negative to PCR positive. The fourth and final question is, what is the efficacy of the novel neuroprotective compound in Parkinson's disease? Neuro-EPO, a new formulation of the erythropoietin with a low content of sialic acid, reported good results in animal models and tolerance in healthy participants and Parkinson patients. In a double-blind randomized placebo, 25 Parkinson patients were assigned randomly to neuro-EPO or placebo groups, and we reported the tolerance of the drug. We recorded resting state EEG before and 6 months after the administration of the drug and obtained the Vareta sources. Here you can see where the data set is available, and we measure the brain state with the first principal component of all the QEEG sources over all the frequency. The loadings of this component are shown in the right bottom on the slide, and the Parkinson patient who received EPO had a better performance in cognition. This brain state component explained the 63% of the cognitive improvement. Conclusion. The QEEG can detect brain impairment in presymptomatic patients with Alzheimer's mutation before the first cognitive impairment appears. Second, the QEEG reveals the long-term impact of early malnutrition in the brain and cognition. 3, the QEEG allows to detect difference in the brain electrical activity between COVID pandemic patients with negative or positive PCR and normal healthy control. And 4, the QEEG can be a proxy of brain state to know the influence of the neuro-EPO on cognitive performance in Parkinson's disease. Thank you very much.